Hey guys, welcome back to our channel Glitched Velocity. I'm your host Wazahat, and today in this video I'm going to show some JavaScript commands that we are going to see in the next update of CopperCube 3D game engine. So without further ado, let's get right into the topic. As you can see on the screen, I have some JavaScript command listed over here. So the first one is ccb get animated joint count, which will return the number of bones or joints of an animated scene node. I also have this test.ccb file open in my computer, which is nothing but just a new CopperCube project file. So I'm going to import an animated object in my scene. I'm going to use this animated clerk. So double click it so that it will appear in our scene here, because we need to use an animated object in order to execute this ccb get animated joint count command. So then we are going to attach a new behavior triggered by event when a key is pressed to something, and I'm going to change the key from A to F, and then I'm going to attach a new action by going in special, then execute JavaScript, and then we are going to write our JavaScript commands in the script editor. So first we are going to create a variable named clerk, which will return the animated object, which is our clerk. So we are going to call it by ccb get scene node from name. And we know that our animated object has a name, which is clerk. We are going to type clerk here. And then we are going to create another variable for the total number of bones or joints of this animated object. So I'm going to create a new variable and call it joint count. And then we are going to use the command ccb get animated joint count. So I'm going to copy from it here, and then I'm going to paste it here, and then simply feed our animated object to this command. And then we are going to print the total number of bones in the debug console. So I'm going to use print joint count, and then hit OK, then hit OK. And if I save it now by clicking this icon or by pressing Ctrl S, and then if I execute this glitched velocity application on my desktop, which is an extended version of CopperCube application player with the extended JavaScript command supported. So if I open it, it will open the saved CopperCube project. And if I press F, then this should print the total number of bones or joints for this animated clerk. So if I press F, as you can see, it printed 36, which is the total number of bones for this animated object. And if I go to editor, if I select this animated object and go to modify selection, then attach a node to animated joint, then you can see all the bones or the joints mentioned here or listed here. And the next command is ccb get animated joint name, which again uses an animated object. And instead of returning the total number of bones, it returns the name of the bone of an animated object. So I'm going to simply copy it from here and then go back to our behavior. And then I'm going to replace this ccb get animated joint count with ccb get animated joint name. So I'm going to replace it with this ccb get animated joint name. And then we are going to provide a joint index here, and I'm going to use 5 here. Joint index starts from 0 to the total number of bones. And if I hit OK and save it, and if I execute this glitched velocity application, if I press F, then it should print the name of that bone on the joint index 5. If I press F, it print veteran 01 right foot ankle. So right foot ankle. And if I close it, go here, go to modify selection, and then attach node to animated joint, then we can see we have 1, 0, 1, 2, 3, 4, 5. So we have veteran 01 right foot ankle on the 5th position. So 0, 1, 2, 3, 4, 5. We have veteran 01 right foot ankle. All right. The command works perfectly. And then we have ccb get current animation frame, which will return the current animation frame playing in the scene for that animated object. And we are going to use this command now. So go back to our behavior and replace CCB get animated joint name with the new command. And we are going to remove this joint index as well. And if I hit OK and save the application, I execute the glitched velocity application on my desktop. And now if I press F, it should print the current playing frame for this particular animation, which is 12, 35, 21, 10, 9, 33, 25, 23, and so on. And if I go here, select this, right click, go to modify selection and open in animation editor, then you will notice our walk animation starts from 0 to 36. So it is not going above this 36 value here. So it is always going to print in between 0 to 36. But if I select this run command here, or sorry, the run animation here, then you will see that it ranges from 36 to 54. And if I go in the attribute settings for this animated object and change the animation from walk to run and save the project by execute glitched velocity application, then you will see our animated clerk is now playing the run animation. And if I press F, then it should print a value in between 36 to 54. So you can see it will not print any value below 36 or higher than 54. So it is returning the current playing animation frame of this animated object. And now we have the CCB set current animation frame. So we can also set it animation frame for our animated object. Let's just switch back to walk animation and go back to our behavior where we have attached our execute JavaScript action. And then we are going to replace this CCB get current animation frame command with CCB set current animation frame for our clerk. And then we are going to provide which animation frame we want to play from. So let's say 10. And if I hit OK, and if I save it now, open glitched velocity application. And if I press F, it will not print anything, but it will print something that it is not defined or something like that. Or it will simply print 0, but it will change the animation of this animated object to play from 10th frame. So if I press F, then you can notice it is playing from 10th frame, but in the debug console, it is printing 0. So it is playing from 10th frame. Whenever I press F, it set the current animation frame to the 10th frame. And then we have this command CCB set animation from Scenenode. And in order to show this command, I'm going to download some other animated objects from 𝙎𝙬𝙧𝙘𝙀. So I'm gonna open 𝙎𝙬𝙧𝙘𝙀. Sorry, I made a mistake here. Not opening. And let's just wait. I have to log in. So, all right, we are logged in, and now we are going to download some animations. So let's say this one, shoved reaction with spin on this ninja model here. Let's say this taunt one. We are going to download it with the skin. Just Wait a moment. And I'm going to download it on my desktop, taunt.fpx. And then we are also going to download this defeated. Let me just change the character first. Let's say we are going to use this 𝙎𝙪𝙧𝙘𝙚. Sorry if I'm not pronouncing the name correctly. We are going to download this defeated animation on this character. And then we are going to import both the animation in our CopperCube project. So we have taunt.fpx and it will take some time to load. And I'm going to scale it down, maybe something like 0.2, 0.2, 0.2. All right, we have our model here, and then we are going to add texture to our ninja. And then we are going to import another object, which is defeated.fbx file. And it will open the new character with the defeated animation applied. Then we are going to attach the texture for defeated.fbm folder. Sorry. All right. And then I'm gonna scale it to the ninja model. All right. We have two different models, animated models with two different animations. And I'm going to apply this defeated animation on this ninja model. So let's just go to animation and change it to 𝘎𝙎𝙪𝙙𝙘𝙗𝙪𝙗𝙚. All right. So this is playing the taunt animation right now, and this is playing the defeat animation. But I want my ninja to play the defeat animation, and I know that they both have the same skeleton. So I can do that easily with this new command here, which is ccb set animation from Scenenode. So I'm going to use this command. And in order to use that, we need two scene nodes, node 1, node 2, and we need to use animation name. And our animation name is 𝑚ixamo.com. So simply go to our behavior where we have our execute JavaScript action. And then I'm going to copy this and paste it here. And I'm going to call it ninja. And I'm going to call it soldier. So variable soldier and variable ninja. So we have our two scene node. First one is our soldier, second one is our ninja. And I'm going to remove this variable joint count. And now I'm going to simply copy this command from here. CCB set animation from scene node. And then I'm going to paste it here. And we want to apply this animation on our ninja. So first we are going to provide our first scene node, I think. And then we are going to provide soldier here. And then we are going to provide the name of the animation, which is 𝑚ixamo.com. And then I'm going to hit OK. And then I'm going to save it and execute the application. So we have our ninja playing the taunt animation and our soldier playing the defeated animation. When I press F, it will either switch the animation from ninja to soldier or from soldier to ninja, because I'm completely lost about the node 1 and node 2 combination. So if I press F, it says joint count is undefined and could not set animation provided but Scenenode is not available. And that's because we haven't changed the name here to Ninja and Soldier. So first we need to change name here. So I'll go to attributes and change it to Soldier, because in our JavaScript command, we have provided name for this Scenenode as Soldier and Ninja for this Scenenode. So if I press Control S to save the project, and if I execute the application now, and if I press F, then you will see our Ninja is also playing the defeat animation. So now both the animated models are playing the same animation, while our Ninja has no defeated animation. So this command is really useful. You can use one object with all the animation, and if your second object has the same skeleton, then you can use animation from that first object or the object with all the animations. So it will save you some space or file size of your game. So this is how you can use this CCB set animation from another Scenenode command. And then we have CCB get animated joint position, which will return the position of a bone or joint of an animated object. And we are going to get the position of, let's say head of this Ninja model. So if I go to modify selection, then attach node to animated joint, and if I check which one is the head, so 0, 1, 2, 3, 4, 5. So joint index is 5 for the head, and we are going to get the position of this head joint of our Ninja model. I'm going to delete this Soldier model from here, and then I'm going to simply attach a new node head. So we have this 𝘋𝙤𝙧𝙘𝙗 head here. So we have our head here. And then we are going to go back to our behavior, and then we are going to make some changes to our code. I'm going to remove the Soldier, and then we are going to copy paste this command from here. CCB get animated joint position. And then I'm going to simply replace this command with this over here. So we have our Ninja, and we just need to provide our joint index. So we have to provide our animated node and joint index. So I'm going to provide joint index 5, because we know that the head joint is at the 5th index of joint. And we are not going to print anything, so I'm going to remove that as well. So we have our Ninja, and we want to get the position. Actually, we want to print the position. So I'm going to call it variable pause is equal to CCB get animated joint position. And I'm going to change it pause here as well. So we have this command, and if I hit OK again, and if I save it and execute the glitched velocity application, and if I press F, it should print the position of the head bone or head joint. So it is printing the head position, but you will notice it is printing different values when I continuously press F. And that's because it is moving his head, and the joint position is changing when the animation is playing. And in order to prove that the joint is showing at the current position or the correct position, what I'm going to do is I'm going to create this cube mesh over here, and I'm going to scale it down. And make it children of this 𝘋𝙤𝙧𝙘𝙗 head rig, so that you can see it is moving. And let me just move this cube mesh. here at the head position. So now you can see that the cube mesh is also moving. So that means it is changing the position whenever the animation is playing. So that's why we are getting these different values when I press F continuously. So sometimes it gives me 0.130432 for the x-axis. Sometimes it gives me minus 1.390005. And that's because our animation is playing and the head joint position is changing continuously. And that's all for animated objects. And now we have the CCB get texture width, which will return the width of a texture. And we are going to use our cube mesh for that, and gonna delete the Ninja model. So we have our cube mesh with this texture applied, which is of 1024 by 1024. So we know that its width is 1024 and its height is also 1024. But when during the execution of game, or when you need to supply values or the resolution of texture to your shader program, you need this command. So let's just go back to our behavior, and then we are going to provide a texture. So I'm gonna change this here by renaming the variable to text, and then simply writing CCB get Scenenode material property, Scenenode material property, and then we are going to use Ninja. I know that we have removed Ninja, but we are going to rename our cube mesh to Ninja mod. And then we are going to supply the material index, which is 0 for our cube mesh. And then we are going to use the texture1 property, which will return the current texture that is applied to our cube mesh. And then we are going to print the width of our texture. So we are going to use this command CCB get texture width, variable width is equal to CCB get texture width, and we are going to provide our texture here, which is text. And if I hit, we also need to change this pose to width because we are going to print the width of the texture. If I hit OK and go to attributes of this cube mesh and then change it to Ninja. And if I save and if I press F, it will return the width of the texture, which is 1024. And let's say this one has 512 by 512 resolution. And if I apply this as texture for our cube mesh, and if I save it, execute the application, and if I press F, it will return 512 as the width of the texture. You can use some other texture with 256 by 256 resolution, and then execute the application, press F, it will return 256. And same way it will return the texture height. Then we have CCB set mouse position. I'm not going to show these sound commands because I don't have a sound file, and I'm not going to search for royalty-free sounds. So we are going to leave these commands, but I want to assure you that all of the sound commands are also working. So then we have CCB set mouse position, which we can use to set mouse position on the screen. Let's simply go to our behavior and use the command here. Copy this from here, CCB set mouse pose, and then go to our behavior, paste it, and simply provide a position X. And let's say I want to change my mouse position to something like 0 on the X-axis. and 50 on the y-axis. And let's just save it. And if I press, you can see the green cursor. And if I press F, you can see it is moving continuously on the border or the edge of the application. But as I'm using an FPS camera, it is also switching back to the center of the screen. So I'm gonna create a camera here, a simple camera. And if I save it, then it will show my mouse cursor. And if I press F, then you can see my mouse cursor automatically moves here. So wherever my mouse cursor is, if I press F, it is going to move at the exact position on this screen here. So let's say if I make my mouse position here, and if I press F, it is going to be there. If I move my mouse here, and if I press F, it is going to be there. If I move my mouse here on the top right, and if I press F, it is going to be there every time I press F key. So if I press F and if I try to move my mouse, then you can see it will change its position back to this exact location. So this is how you can use the CCB set mouse position command. And then we have CCB render to texture. This command is really useful. So in order to use this command, we need a scene node, we need a camera, and we need a material index, and we need X and Y resolution. It is always the screen X resolution and a screen Y resolution. So it is going to be your screen height and screen width. So let's just use this command. We are going to copy this CCB render to texture. Go back to our behavior. And then remove this CCB set mouse push command and attach this command. Provide our node. We know that our node is Ninja, which is actually a cube mesh, not a Ninja model. And then we need to provide a camera. So I'm going to use CCB get active camera. So we have CCB get active camera, which will return the current active camera of our scene. And then we are going to use CCB get screen height or screen width, but I know that we are going to use 800 by 400 maybe, or 600 as our screen resolution. And then if I hit OK, and now I'm going to create a terrain in order to show texture correctly. And yep, if I execute the application, wait a second. Yeah, and it is not showing the terrain because I haven't saved the project yet. And I'm going to change this camera to a FPS camera. So I'm going to create a new camera, let's say free flying camera or FPS camera. I'm going to create a first person shooter style camera here. And now if I save the application and open this glitched velocity application, so where is our cube? Oh, let me just move down my cube so that we can see that easily. All right, we have our cube mesh on the ground. And if I execute the application, there is our cube mesh. And if I press F, then it says cannot render to target wrong amount of parameters. And that's because we have our node, we have our camera, but we haven't provided a material index. So we go back to our behavior. And then we are going to provide a material index. And we know that it has a material index of 0. So we have provided the node now, and camera and material index and X resolution and Y resolution. And if I press OK, OK, and save the application, and if I test it now, if I press F, then you can see it has applied the current view on this cube mesh. So if I press F again, then it applied this view from the current active camera. If I apply this here, then you can see it applied wherever I'm looking as a texture on this cube mesh. So if I look here on this tree, it will apply that as a texture on this cube mesh. Don't worry about the debugging console because it is printing or giving us error because we have unused command in our code, which we can remove by going in here. So we have this variable width, which we are using to get the texture width. But if I remove this command and save the application now, and if I press F, then you will not see any error in the debugging console. You will also notice that it is not printing or capturing the texture of this cube mesh. It will only capture the area and will ignore the object on which the texture is applied to. So we are using our cube mesh to apply the texture on. So it is ignoring our cube mesh in our view. So it will capture everything else except this cube mesh. So that's how this CCB render to texture command works, and you can easily use this command to create vertical mirrors or horizontal mirrors or reflections. You can say real-time reflections or something else. You can create, an extra render to camera or something like that. Then we have CCB split screen command, which will require two cameras in our scene, camera 1 and camera 2, and will also require some of the commands resolution. And these resolution are X1, Y1, X2, Y2, which is a box. Like we have X1 here and X2 here and Y1 here and Y2 here. Then we have X3 here and X4 here and Y3 here, Y4 here, and something like that. So I'm going to showcase these commands later in later video or in some other video because this video is getting really longer. So see you in the part 2 of this video, in which I will show CCB split screen command, CCB set game timer speed command, and CCB emulate key command. And we'll also try to show the CCB pause all sound, CCB set Doppler effect parameters command. So that's all for today's video. We'll see you in the next video. Stay safe. Peace out. Bye bye.